Welcome to uh, today's lesson. And today we are discussing all about linked list. So this class is generally covering some data structure and algorithm lessons. So let's start with linked list. Linked list. Uh, Here I have a brief note that we can keep track of all the points that we are supposed to study in this class. So, what is a linked list? A linked list is a linear data structure where elements are not stored at contiguous memory locations. So, it is not like array data structure. If you have studied already about arrays, you know that arrays are stored at contiguous memory locations, like they are after one another. Like there is no space between two between two elements of an array. They are all next to one another at a contiguous location. But linked lists are not stored at contiguous memory locations. They are everywhere, but they have a reference to one another. That is how they are forming or creating a list, and that is how we call them linked list, because every uh, element or every node has a reference to the next node or the next element, and generally uh, every node in that list has two properties. One is the data, like here you see, for example, the data is 12, and the other is a pointer or a reference or a link to the next node in the sequence. That is how they are creating or they are forming a list. Otherwise, they are independent nodes. And as soon as they are pointing to one another, that means they are creating a list. So, how or why should we study a linked list when we already know all about arrays? Arrays are also a list, a kind of list. So there are some advantages in studying linked list or using linked list instead of arrays at some point. For example, the first one is the size. In Java, you already studied all about arrays, and there you saw the size was fixed, constant, static. Like you define the size when you are creating your array. But with linked list, the size is dynamic. You can add as many nodes as you want, as you need. You just create that node, and then the last node in that list points to that new node. Or sometimes you can add new nodes in the middles. And that is why it says efficient insertion and deletion. So when you have an array, uh, so when you add a new element in the middle, you have to push all other elements, either move forward or backward. Or when you delete, same thing. For example, let's suppose you say you have an array that has 10 elements, and you want to delete, for example, the second element. As soon as you delete that second element, that means you have to move backward all other eight last elements one step to the toward the first node, toward the head, because we said that arrays are at contiguous memory locations. There is no space between two elements of an array. So when you remove uh, an element from the list, that means that space cannot be left empty. You have to move other last elements uh, toward the first node in order to fill that empty space. So that is a lot of that takes a lot of time, and that's uh, very difficult to manage the memory like that. And that is difficult. So because you have to touch all the nodes. I said 10 elements. Now suppose you have like thousands of records, so you have to move all the thousands of records. That is difficult. But with linked list, insertion and deletion is easy because you just change the pointer. That's it. So, and can be used to implement other data structures like stack, queue, graphs. So these are another other useful points about linked list. And there are three different types of linked list. Single linked list, like you see the example here. Here is a single linked list. Double linked list. Here, see every node has one pointer or reference to the next node. But when it comes to double linked list, there they have two pointers. Every node points to its previous node and its next node. We will study that in details in our next lessons. And circular linked list, it is that the last node points back to the first node, forming a circle. So the name actually makes it clear. So, for example, in this single linked list, if this last node again points to the first node, that means there you see a circle. So, a single linked list node structure in Java. So, we explained that the linked list is a kind of linear data structure where elements are not stored at contiguous memory locations, and every node has two properties. One was the data and the other one was the reference to the next node. So now, how do we create a linked list in Java? In general, in order to create linked list, we need two classes. One class should be the node class that contains the information and reference to the next node, and the other one is the linked list class itself, where it manages the list, storing a reference to the head, and providing methods for insertion, deletion, and traversal of that linked list. So now, well, let's create a linked list example here in action, and to see how how we can create that instead of tracing this already written code here. So let's here come to the Eclipse. So based on these definitions, in order to implement a linked list, we need two classes. One class should be the node, and the other class should be the class itself. So let's create a new Java project. Next. So let's give a name. Let's say linked list tutorial. Finish. So we created a new project, linked list tutorials, and now we said we need two classes. Let's create our classes. One class should be our node class. You can give it any name. I'm giving it a node just to make it clear and informative for you. So it is the node. Finish this. And we said that every node has two properties. One property was the data, like in this example it shows. One property is the data. So let's say init data. And another property is a reference or link to the next pointer. So the data type should be of its node type. Node next equals the property is one is the next and one is the data, and let's define them use in the constructor, give them the values node. So And remember one more thing here. Whenever you are creating an instance of this class or an object of this class, so you pass the value at that time of at the time of the creation. So init value, you can give any name you want, like that is not fixed. So this value should be passed to the data equals value, and the next has no is pointing to nothing in the beginning, points to null. It is the node that we have here. This class exactly represent this node. See, it has two properties. One property is the data, like 12, and the next property is the reference to the next node. So it was one class, and we need the linked list class also. So now let's create another class. It is the linked list class itself. Linked list. Finish. So the linked list itself, it actually it is a pointer or a reference or a link to the first node. See, here we have a node class, and then we can create as many instance or object of this class as we need. However, how can we call it a list when the linked list points to the first node in the list? So it has one important property, and that is the head. And the type is, of course, from the type node, because it has to point to a node. So it has to store the address of a node. And mostly the name we give it head, node head. So that's it. And at this point, we are not giving any value to the head, because as soon as we create our list, at that time this head has to point to the first node. Now let's create our main method also. So I create another class to have the main method to see how we can form this list. So let's call it like main class, or initial. Oh, main class is fine, but you can give any name that is informative and that has meaning to you. Main class, so it should have the main method, because from this point we are running the project. Finish. Okay, so we have two classes here. One is the node class and one is the linked list class. So, and this node has to represent like this, has to be represented like this, where each node points to one another. However, how we call it a list? So this linked list, this head property has to point to the first node. So now come to the main class, and here first create this. For example, we need 3 nodes. So node n1, node 1 equals new node. So we say that when we are creating the object or the instance of this class, so we pass the value at that time. So the value is 12, and node 2 equals new node. The second value is 99, and node n3 equals new node. It is 37. Okay, so now we have 3 nodes here, but now it is not a list, because we said we call it a list when each node is pointing to one another, and the head property of the linked list class points to the first node. That is when we call it a linked list. Now it is not the list. So how to form the linked list, how to create the linked list? So first, make this head point to the first node, point to this number 12. So let's create an object of this linked list class. Linked list class list equals new linked list. Okay, we have an object of the linked list here, and it has one property, and this property is pointing to the first node. So we say list dot head equals to node 1. Now we are creating our list, but still it is not a complete list, because node 1 has to point to node 2, node 2 has to point to node 3. So we say node 1, it has a value called next. Using that next, it has to point to node 2. Same thing with node 2. Node 2 into dot next, it has to point to node 3. Something like this. And node 3 points to null, which by default next is pointing to null. So we don't have to do anything else here with that. See, now we have created this list here like this. We first created a node class and then created its instance or object here. And then we have a linked list here which has one property, and we have an object of that linked list here, and that property of the linked list points to the first node. List.head equals node 1, and then node 1.next has to point to node 2, and node 2.next has to point to node 3, and node 3.next it points to null, so you don't have to make anything extra here. Now this linked list is represented like this. So after this time in actual programmings, you are not creating a list like this. I made this basic approach just to make clear that what does it mean to say linked list, what does it mean to say the nodes reference or points to one another, or the head points to the first node. So I hope now the concept is clear. But after this time, we are creating all our methods in the reference in the linked list class to insert new node, to delete new node, or to traverse the linked list. For example, here you have this linked list. Let's suppose you add a new node here, or you delete this. So we are adding all those methods and operations here in the linked list. Or when you add nodes in the class in the linked list, so also here you create a method for that and just call the method and pass the value to that method, and that method has to do all these operations. For example, here first we created the object, and then we made the next value pointing to the next node. So after this time, we are making methods in the linked list class for all these operations, and we just call the method. So that was all for today, and in the next lessons we will learn how to insert new node in the linked list and how to remove node from the linked list. Until then, have a nice time.